to enterprise consulting, which is what we're doing now. Started as delivery, and in engineering, I was in data centers, campuses, branches. I was actually, hands-on with configurations of route, switch, wireless, etc. And then I moved into pre-sales about 3 years ago. So I definitely hold on to that mindset of what I cultivated, of a blend of hands-on engineering and strategic insight, helping customers. I really love looking at zero trust ideologies as well as secure network architectures. If I had to identify specialties, I love vendor neutral ideologies. To me, network engineering is different than like a OEM based type of engineering. I've got certifications and in no particular order, Fortinet, Dell, Juniper, Cisco, etc. Some SD-WAN certifications in there too. But if I had to look at some specialties, it would be vendor neutral, SD-WAN, Sassy, with what we're talking about now, microsegmentation, whether that be user microsegmentation, like network access controls, or data center microsegmentation. And then I'm definitely diving into a lot of wireless nowadays. So if you'd like to connect, I'm on LinkedIn. It's Philip Glinski with 1L. And my email is below that. It's just phil.glinski@anm.com. So if you have any questions that you're not particularly want to have in the public, please feel free to send me an email or connect with LinkedIn, and I'll give you a thumbs up whenever I see you have any promotions that are probably well deserved. So enough about me. I want to talk about our agenda today. I want to talk about some definitions because I really feel like that's extremely important for setting the table stakes about the rest of the conversation. I want to set the stage about how networks were pretty much architected, and then the timeline of how we got to where we are now today. And then we'll do some whiteboarding in between there. I'm not a huge fan of PowerPoint, so I'm gonna do a little bit of PowerPoint, whiteboarding, a little bit of PowerPoint, more whiteboarding. And this is interactive, so I'll be asking questions. I would love, if somebody has a question, you can raise your hand, or, if you want to jump off mute, and go ahead and feel free to jump in. Finally, we'll do a quick summary, some recommendations, and then lastly, a call to action. So I'm going to take a quick sip of water before I jump in here, because this takes a minute to load. So when we talk about SASE, the definition is it's a combination of two different items. So SASE is SD-WAN, software-defined wide area network, as well as security service edge, okay? And SD-WAN is basically the foundation and the launch pad, all right? There's a whole other arm of points for that, but I'm not including that. I think a lot of us are pretty familiar with SD-WAN. If some people are not, basically we're separating the control plane from the forwarding plane, and we have kind of like a localized orchestrator is the word that a lot of people use for handling routing in their environment, okay? That is kind of the base. That's kind of the launch pad is what I call it. Now, SSE, Security Service Edge, is the cloud-delivered security functionality that complements SD-WAN and creates this whole ideology of SASE. So let's start with the first one, SWG, which is Secure Web Gateway. And basically, it's UR filtering, AVC, App Visibility Control, anti-malware. Basically, because web is in the name, Secure Web Gateway, we're looking at anything on port 80 and 443. We're looking at HTTP and HTTPS. This is the traffic that's kind of traversing, okay? Next up is ZTNA, and this is Zero Trust Network Access. Some people kind of mix that up with Zero Trust Network Architecture, but for this instance, ZTNA is basically Remote User VPN Replacement Solution. With SASE, that is one of the largest lifts and shifts, but is also one of the, I guess, I would say one of the most, it's one of the last items that a lot of companies move to replace. But once you do that, it's really a big breath of fresh air. You have a lot of moving room beyond that. It's basically like the anchor that holds on to this old ideology of networking. And I'm going to get to that in a minute when we get to the whiteboard. CASB has been kind of hard for a lot of people to understand, but it's Cloud Access Security Broker, okay? And the best way to define this is you have your personal OneDrive and you have your corporate OneDrive. And if you're able to log into both on your corporate laptop, you would be able to kind of transfer files. And it doesn't have to be OneDrive for Microsoft's sake. It could be like Microsoft OneDrive and my personal Google Drive, and I'm transferring sales documents and files, right? CASB stands in line to lock that down, right? We can do this now with APIs, but that's kind of the older way of doing it. This is the example of how it's a cloud-based security feature. It's kind of standing in line with that process. Next, we have firewall as a service. This started as 80 and 443, but now it's evolving. We're handling all ports and protocols. So in order to identify those ports and protocols, they had to evolve and create policies via other mechanisms. So this is layer 3 through layer 7 policies in the OSI stack. It's complementary to SWG or Secure Web Gateway. Next is browser isolation, which I think is really, really cool nowadays. Basically, RBI or remote browser isolation, what it allows you to do is to look at risky traffic. So instead of my laptop having a web session between my laptop, me as a user, and like a dirty server online, what it does is it uses sandboxing technology and it streams that connection to my machine, but it's in a cloud base, and you can actually click on that payload and it can be detonated in that sandbox before it ever reaches my laptop or anybody's laptop to cause issues. This cloud-based browser, it's designed to be a black hole and to keep things secure, and it can be deleted, so it doesn't mess obviously with anything in the cloud, which is great. Next is data protection, or a lot of people say DLP, which could be data loss prevention or deep level packet inspection. But basically, we're looking at PII, or personable identifiable information. So think of like PCI compliance, HIPAA standards. You don't want people's social security numbers, credit cards, bookkeeping records, being exfiltrated from the environment. So data protection encompasses all that. It blocks that traffic from being exfilled. Decryption is next. Every single time I talk to anybody, the amount of percentage goes higher for encrypted traffic. The number that I know everybody throws around is 80% of all internet traffic is encrypted. It's HTTPS. So if you want to inspect that traffic, or if you want to scan that traffic for malware, or for people trying to exfiltrate data via HTTPS, so it looks like it's trusted, it needs to be decrypted. And it needs to be validated that the traffic is valid. Obviously, we don't want the PII or any sort of malicious intent, so decryption is the way to go with that. And then lastly, there's a few other, but I'm trying to combine them into this one bullet point. So there's DNS security. This is advanced application telemetry, so advanced visibility, asset classification, and because a majority of these SASE products, if you will, live on an agent on a machine, that gains telemetry into the end user's machine and from its viewpoint, right? So they found a way to call this like DEM, digital experience monitoring, or digital experience management. Depends on who you ask or talk to. There's a couple of different flavors depending on OEMs and their go-to market strategy. But basically, it says, well, we're looking at all the connections that these users and their laptops are going to, no matter where they're located, at a cafe, in an office, or on an airplane. But when somebody opens up a ticket and they say, for instance, Salesforce is down, we have the telemetry and we have the data to say, well, no, actually, you're trying to get Salesforce on an airplane and everyone's trying to stream the movie that they want to watch. So traffic is really, really bad. Or, the internet is very, very bad in your part of town this time of year or whatever. So they can basically say like, it's not Salesforce, like it's one ticket, it's one user. You know, we can extrapolate that and know that it's not Salesforce is down, but it really helps the operations team with helping to explain that to users for ticketing purposes. All right, so now that we have the table stakes kind of taken into consideration, what I want to do is I want to set the stage for how we looked at this traditionally. So what I'm going to do is I'm going to jump off camera, if I can do that, unless you guys want to stare at the top of my head, which I doubt. So we turn my camera off. No, it's not going to do it. All right, I'll just leave it on. That's fine. So what I'm going to do is I'm going to share from my tablet here. I'm going to start the broadcast. Hopefully it takes over easily without any issues. And it looks like it did take over. Can you guys see it okay?
Looks great.
Thank you so much, Amanda. I appreciate your help. Okay, so I'm just going to use Freeform on my iPad here just because it's easier. And what I want to do is I want to talk about kind of how we got here. We're going to set the stage. What we're looking at is we used to build networks like fortresses, okay? And the center of our universe of this fortress was the data center, okay? It had like one gate, one drawbridge. It was one way in, one way out, castle and moat. And this is where everything lives safely inside, okay? For instance, we had private applications, right? Private apps. These might be like our business platinum critical applications. We had some hyper converged infrastructure. We probably have a few virtual machines. We've got data, right? This could be storage like SAN, or it could be like a SQL server or something like that. And then we have like traditional network items. We've got some switches. We probably have a couple routers. And we protected the outside, it's kind of agoraphobic, if you will, with security protocols and tools, okay? We had intrusion detection systems, intrusion prevention systems. We probably had a firewall. We might have like a proxy, like an F5 or something similar, maybe some load balancing too. We might have had some deep level packet inspection. And then the big one was also VPN, right? But basically the ideology was as follows. We had this crunchy outer shell that protected the soft, chewy inside, okay? And for every single connection, we had other locations, right? Maybe for some users, we had like a single data center, right? But what did we do? We actually took this and we made a secondary data center, okay? And let's say we had some growth in the company. So what did we add? Well, we might have had, oops, let's go back here. We might have had like a branch. We might have had headquarters that was opposite the data center, maybe when we moved. We probably have some other remote sites. Like we can call this like a campus, right? We probably have some remote users, not a whole bunch, but we probably have some remote users. And then we had like third party, okay? And how did most of these people connect, right? Well, what we did was we had, in the branch, we had a router, HQ, we might add like 2 routers. Remote sites and campuses, usually just one suffices. Remote users just use internet, third party, maybe we'll do like an IPsec tunnel, right? But if somebody wants to come off mute, what was the really expensive line of communication to connect all of these data centers to remote locations? Anybody? All right. Well, if somebody screamed MPLS, I didn't hear it, but it was MPLS. All right. This is how our data centers connected. Okay. This is how all of our branches connected. This is kind of our standard, right? We might have remote users that like went to the internet and came back. So why don't we just add that here? So we've got kind of our traditional internet here connected. We have, can't forget the big 3, AWS became pretty popular. Let's don't forget Google Cloud, GCP, and Azure. Can't forget them. Okay. All right. So all of these were kind of intertwined, intermingled. And then we probably had, if your organization, I don't know why I'm not getting any color, we probably had some organizations that moved some applications to other providers. So we'll call those are SaaS providers, software as a service. So let's name some software as a service. We've got Office 365 was a big one. We've got Salesforce, which is a big one. And then that's a good representation. Okay, so this is kind of how we understood the network back in the day. Okay, but then as we evolved and things changed, what happened? Well, we had the users inside the data center. They moved. Where did they go? They went to cafes. Okay, they had the road warriors. We've got virtual machines that are instead of renewing like with Broadcom or whatever, maybe they're like, okay, we're going to move that to Azure, right? Those are our platinum applications, right? So for the remote users, they left the castle. Laptops, cloud applications, remote workers, they left the castle. Therefore, this perimeter, in essence, vanished overnight, okay? What else? It was kind of ironic because the security teams and the network teams were still working on these security applications. But when you're a road warrior and using internet to connect to a SaaS application, you're kind of outside of their scope, right? And then the biggest thing that a lot of people had was a realization that for a branch user over here, and let's say we moved one of our platinum applications to SaaS, for this branch user, they would have to go through the MPLS, go through the security stack, go through routing, go out the internet, wrong way, go out the internet, go to the SaaS application, and then double back through the entire stack. So what did we always hear from people that like adopted a new SaaS application in the cloud? Branch users that were really far away from that application were complaining about latency. The users complained. CFOs got the MPLS bill because there's more traffic traversing double. It's hairpinning through the data center. So that basically lit the fuse for Sassy. Okay. So I'm going to take over. Let me end this real quick. Stop this. Let me share this again. It's this screen here. We're back on the main screen here.
Yep, looks all good. And I want to say shout out to Tracy for getting MPLS. She put it in the chat.
Tracy who?
From Western Alliance Bank.
Tracy Wallace, thank you. He's a great guy. Tracy's awesome. Okay. Okay, so here's the timeline, okay? Because the applications were moving to the cloud, because the users, we can't corral them anymore, this is what happened, okay? In August of 2019, Gartner actually coined the term Sassy. It's from a couple analysts, Neil McDonald and Joe Scarupa. I know 99.9% of us can read, but I want to read this one because this one's actually really important. Their message is very simple yet disruptive. Networking and security delivered from the cloud closest to the identity and device, not the data center, right? So this is basically saying that the data center is no longer the center of our universe, right? The cloud is, the internet is, okay? A year later, and this is late in 2020, NIST, the National Institute of Standards and Technology, wrote a 60-page document, like 64 pages of document. It's the number is 800-207, and this references zero trust architecture, ZTA. I'm gonna, unless you want to read it, which go ahead by all means, but the three biggest bullet points in there, and I'll summarize, are as follows. There's no implicit trust for any users or their assets based on their physical location or their connection to the network. So it doesn't matter if you're a cafe user via the internet. It doesn't matter if you're at home via VPN. There's no implicit trust given to them. You were giving everybody the least amount of privilege to do their job, right? So we're not just going to like give them extra access and then kind of reel it in. No, it's the bare minimum every single time. And we're going to assume that there's an attacker present in the environment basically at all times. So that's why we check often. And this sucks because a lot of people who don't understand this, they're like, well, I'm me. I have my multi-factor authentication. I'm trying to get to this application, but it keeps on asking me, 4 times a day. Well, we don't know when you're going to check on a phishing email and get malware on your laptop. So therefore, that could happen between the first and the second login or the third and the fourth login. But just to be safe, we're going to check every single time, right? So in summary for those items, SASE was invented first, the term. NIST simply outlined the zero trust principles that made SASE the dominant architecture for our modern networks. They complement each other. They're used synonymously, but they're pretty different, obviously, in ideologies, okay? And then we have to talk about the elephant in the room. I call it the honorable mention. It's COVID, okay? This made SASE relevant. We were already on the path to getting to SASE being adopted, right? It was already in motion. However, COVID made it instantly relevant because remote users needed identity-based access, and they needed it quickly. VPNs basically were melting. If anybody was in the network industry or helping any customers during that timeline, when everybody was working from home, the first things that collapsed were the VPNs, just for pure, lack of a better term, they hugged it to collapse. And then cloud apps became the norm. They said, why are we paying to house these applications when everybody's working from home and they're using the internet? It's probably a wiser idea to spend around the same amount of money and just move it to the cloud. Obviously, we're not Microsoft, so we're not doing O365 or Salesforce, but those are the options that were available to us, right? So SASE went from future trend to urgent requirement because of COVID. It simply accelerated it. It wasn't the reason, okay? It fast-tracked it, all right? So now let's talk about the glow up. And I'm gonna go back to, sharing on my WebEx here, on my tablet, excuse me. So let me take over again. Start the broadcast. Let's see when this pops up.
Looks good.
Okay, thank you so much. I'm gonna get a sip of water real quick. So in the second or third slide that I had, what do we talk about? We talked about SD-WAN, right? So I'm gonna take this data center, I'm gonna duplicate it, and then I'm gonna drag it way over here because I want a new area to work on, okay? So we have our data center. Maybe we have 2 of those and duplicate it. I kind of same ideology. And then we have the same thing again down here. I'm gonna go to my pen. We have the same thing down here. We've got our, nope, don't need the ruler. We've got our branch users, HQ, campus, remote users are huge now, right? Remote users, let's do third party, and then the cafe model, okay? So these are where people work nowadays, okay? SD-WAN doesn't apply to all of them, but basically for a majority of these, that's probably the first 3 here, okay? So we said, I don't want to use MPLS anymore. Let's use multiple links intelligently, like broadband, LTE, MPLS, and satellite, which is becoming huge. I know like Amazon Leo has like that fixed satellite, which can go direct to, it has an express route built in, which I thought was pretty cool. And there's a couple other satellite ones too. We can save that for another conversation. I'm very passionate about that one. But basically we said, we're going to look at all these other options and we're looking at route-based applications. So therefore performance improved and cost dropped, okay? So at a branch, we have MPLS, maybe 2. HQ, we definitely have 2 routers. Campus, we have a router, okay? These routers, where instead of traditional routers via MPLS, we said no. I get a finer one here. We said no. These are now SD-WAN routers, okay? They still use the same underlay, like if you will, But what did we do? We got rid of MPLS. And we said, well, how do these connect now? Well, it's the internet, right? What's the underlay normally is the internet here, right? Okay. Remote users use their home routers. Third-party contractors use whatever they have. Starbucks uses whatever they have, right? So we have the internet there now. Okay. Let's talk about cloud and hybrid real fast too before I keep going. Apps moved to SaaS and users worked from anywhere. The network perimeter for security, as we know, melted, right? Therefore, the traditional castle wall, it made no sense, okay? The SaaS applications are really important here too. So let's write that out. And you'll see where this is kind of going. SaaS lives here. Let's do that again. Let's do O365. Salesforce. Okay. SaaS applications connect via the internet. Let's don't forget about our top three here. Let's do AWS. You can kind of see the architecture's changing a little bit. GCP. These are really bad clouds, apologies. Azure. Right. They all connect via internet. Okay. So the data center now, its main connection point is the internet. It's not MPLS. AWS has internet, GCP, Azure, SaaS, right? If we were to try to corral this, right? If the security stack here were to try to corral this, we're going to try to do AWS, GCP, Azure, SaaS, O365, Salesforce, branch HU campus from Azure's third-party cafe. That's next to impossible, right? And that's the crux of this entire argument, if you will. If everything is moving to internet first, cloud first, shouldn't security live there too? Okay. Businesses are doubling down on cloud. Compliance and audit failures are starting to appear. Security tools that we had in the data center, they're blind to cloud traffic, right? This local internet breakout, they're completely bypassing. Therefore, we've got islands of security. Do we want this entire security stack in each one of these environments? No, because that's adding more boxes. It's more things to look after and more cover, right? So that to me is the crux of Sassy. We went from SD-WAN giving us this connectivity engine to now having to fuse it with some sort of security delivered as a service. Okay, and this isn't about adding more boxes, it's about removing them. And the promise sounded perfect, but everyone wanted in on it fast. And to be quite frank, some people are just trying to go to market faster, and first to market doesn't always mean that you win. Sometimes it takes a little bit of maturity on the behalf of the OEMs to deliver that, right? To instead of just gluing on SD-WAN to some old security stacks, you have to find the right partner. It became critical, okay? So this is what happened. Instead of this, we kind of cross that out. I mean, we still have it in the data center, like it's still valid, but like all of our eggs aren't in that basket. What did we do? We moved it here. Okay, this is Sassy. This is where it lives. Cloud derived, closest to the identity and closest to the assets or the users, if you will. Okay, so the WebSense from Cisco that used to live here in the data center, everybody hated WebSense back in the day. Now everyone loves it because it's SWG, right? CASB, we ported that to the cloud. We've got firewall as a service. It's looking at all ports and protocols. We've got zero trust, network access. This is, again, the VPN replacement, right? VPN, no more, okay? And then we've got remote browser and DLP, okay? So this is the table stakes now. As any user in the branch accesses anything in the internet, it's a single pass to get there. And where are they going? Let's say they're going to the SaaS application. Great. We don't have to hairpin through the data center anymore. That's such a relief, right? And it can still be secured, right? It can still meet the requirements of PCI, HIPAA, large financial institution, whatever it is that the business is going after, or whatever audit or compliance that they're trying to stand within. It can be handled with that, with a single pass without hairpinning. Okay, let's give another example. You've got a cafe, you got a user salesperson at a cafe, and they're trying to log into Salesforce to get their pipeline figured out for the month, right? They have the agent on their laptop. It does a single pass through here. It goes to the Salesforce. Great. What about an engineer? What about somebody like a network engineer working remotely and they need to log in for a maintenance window and they're working from home? Great. They have the agent running on their laptop. They can actually log in to the data center and they can still make their maintenance window changes securely, right? So this is why the VPN is kind of last to be moved. It's like I said earlier, it's an anchor point, is because if you need to get private applications, usually the VPN is the go-to, right? There are some instances where you have like a proxy, another virtual machine that's an extension of Sassy, right? It's an extension of this Sassy, and it's basically a broker, it's a proxy, right? So if I need to get to an application, a private application that's monolithic, that hasn't been ported out to Amazon Web Services, GCP, or Azure, what do? Well, the agent runs here. That same trusted item or broker, security broker, has a virtual machine in the data center and says, oh, Phil's trying to get this platinum application inside the data center. What do? Oh, well, yeah, he's trusted. He can get that. And it just kind of passes it back. So there's still kind of like a checkpoint, even within our own data centers, because they're not just going to give access to everybody. And the data center is still secured. I know for like, a prime example is the first one that I used, the branch user going to SaaS and the salesperson going to SaaS. That's like the first one that pops in my head is Zscaler, Zia, which is secure internet access and secure private access. So it's like internet-based versus private access for applications, right? So there's that. Let me take a sip of water and think. I want to make sure I cover all this before I go to the next slide. Okay, I want to mention this. This isn't a flip the switch event. Okay, it's phased. It's a phased transformation. Identity, policy, harmonization, and architecture design has to lead the way, right? And that's critical because if you don't, obviously, like everyone knows, like if you don't have a good foundation, like the house that's built on top of it will crumble, right? It's an old adage, but it is particularly true, especially with security. But once you take the time and once it's done correctly and it's in place, visibility, control, finally line up with cloud speed, right? And getting this large progressive movement takes time, but once you're there, it's such a breath of fresh air. Let me stop sharing here. I'll stop and then let me share again over here, the laptop. Thank you for being patient while I work through this. Okay. These are recommendations, okay? And it's just like common sense stuff too, right? So we don't want to revamp the entire network all at once, right? It costs too much. It takes too much time. It breaks too many things, right? We need to get the basics down. Now, if your organization has one data center and one headquarters, do you need SD-WAN? Absolutely not. But as you scale out, there's an inverse ratio where a certain amount of branches, a certain amount of campuses, a certain amount of remote users does require additional help, right? So I do recommend local internet breakout for a lot of our large scale customers. Why? Because you don't want to hairpin everything back to the data center to get to the internet, right? That's kind of defeating the purpose. Like you still have this old adage of hairpinning everything to the data center, and you're still doing it, but it's still just internet traffic. But you're trying to tack on this new ideology. So I definitely recommend internet connectivity to all the endpoints or to all the branches as well, okay? Shift to your cloud native offerings as products expire or as their contracts come up, okay? This is just kind of run rate, common sense, life cycle, technical debt is a lot of the terms that a lot of people use. You don't want to pay for brand new firewalls and then 6 months later replace them with a SASE product, right? It needs to be planned in advance, okay? So just do it as things come to expire, but do take the time to work on it and learn about it and make sure that when it is time to renew and change, that you give yourself enough runway to be able to do that, right? Common sense stuff. I will say be open to switching vendors for comprehensive SASE products, but with an asterisk of do your due diligence first. Look at the products you have in-house. Determine, and if you don't like them, at least give them, an hour or two of your time so you can understand what their product set looks like. So that's a great baseline, because then you can make parallels to other product sets. Okay. So even if you're not planning on using it, give them the time, the respect, and let them give you the information for free. And then you can use that to like, oh, they call it that, but the stuff we have now calls it this. Okay, now I'm making those parallels, right? That's how my brain works anyways. So that's why I threw that in there. It should be software based. It should be hardware neutral, right? It doesn't matter what firewalls you're using. Obviously, like a Palo Alto Prisma Access would prefer that you use Palo Altos. Fortinet SASE or FortiSASE would rather you use FortiGate, obviously, in those instances. But for the same reasons that a switch is a switch for layer 2 and controlling broadcast norms, a firewall is doing the same thing for policies, right? This is critical. Single pass scanning for malware and sensitive data, right? We don't want to hairpin things in multiple different products. And then that leads into what I talk to a lot of our customers today about best of breed versus platform. Okay, and there's pros and cons for both. Platform solutions is more like the progressive insurance ideology when you bundle and save, right? The more products you have with them, the deeper discount you get. But some of my customers love best of breed. They want best of breed for each one of those individual ones, and they're willing to pay a premium for that. However, you don't really have one throat to choke. It's you can call one person and scream at them if it's not working appropriately, and it's their responsibility to make that work. When it's best of breed, it's not as bad as going open source, obviously, but you're kind of having to be flexible and kind of patch things together. Okay. And I've said it a few times, identity is extremely important. Okay. And I know that's not really normally in the SASE conversation or even the SD-WAN conversation, but identity is extremely important. And it doesn't matter where you're doing identity. It doesn't matter if it's an Active Directory or Entra ID, the cloud-based version. It doesn't matter if you're doing Okta, okay? It's like any other sort of like DDI solution, which is DHCP, DNS, or IPAM. So for instance, like Infoblox, okay? Or a spreadsheet, right? If we used to get IP addresses in spreadsheets, it was garbage in, garbage out. Like if I went in there and grabbed a /30 and I used those IP addresses for a point-to-point, but I didn't write down Phil grabbed these IP addresses at this time, somebody else came in and grabbed the same IPs, great, we have a conflict. So identity is the same thing. If you don't have good identity for your users, then SASE isn't going to work well for them. If every single user in your environment, from the CEO all the way to an intern, has the same level of access, SASE is useless. Don't do it, right? So this is a nod to having a hygiene exercise of user microsegmentation. Okay, this is your 802.1x. This is your network access control, and these are the AD policies that are kind of helping that be aligned. Okay. So it's really good to kind of have that hygiene exercise. And I'm going to get to that before we get to the call of action. So in summary, we started with one router and one connection. It was simple and controllable, specifically for security, right? But the world scaled faster than our architecture. We invented SD-WAN to connect faster. But connecting faster without securing smarter created risk. Therefore, SASE emerged as a unifying fabric. The network and security finally speaking the same language. But SASE isn't the end, okay? It's the new baseline for how enterprises operate securely in this borderless world. Right? If I had to do everything in the last 30 some odd minutes, and thank you for hanging out a little bit later, it would be that. Sassy isn't the end. It's the new baseline for how enterprises operate securely in a borderless world. Okay. Lastly, what I have is a call to action. Okay. We have 2 types of workshops that we offer for free. Okay. Start on the right side. Don't look at the IAM yet. On the right side, we have the zero trust architecture. Okay. Usually it's a 4-hour workshop. All the stakeholders are there. So security, networking, engineers, as well as middle management, upper management. We've had CTOs and CISOs sit in on them as well, because it is extremely valuable. ANM engineers and thought leaders will come into the office. It's usually in person. It's usually whiteboarding, because I find that is the most beneficial, we find. And this comes with a deliverable. So at the end of that workshop, we have this working roadmap, kind of like this livable or this like breathing document. It's high-level design, suggested solutions, maturity model, and use cases, right? It's basically like we recommend 1, 2, and 3 as priority, and you can knock out 1 and 2 in a week and a half, and number 3 might take a month and a half, and it kind of helps kind of outline that. Naturally, we can help with executing those, and it's not because the team isn't capable. It's more so because we want to help the business and the team get to that point sooner, right? The second one, the last one, is this identity access management, right? Because identity is so important that we have with our security series. Same thing, security, networking, all the stakeholders. We'll do it in person. We can bring lunch, great. But this is looking at your multi-factor authentication, single sign-on, your privilege access management, identity governance, where it's being stored, how it's being used, and kind of just do like a once-over on those as well. These are the foundations, right? And everybody's mileage may vary, right? You may be really deep into SD-WAN. You may be really deep into getting internet into all your branch locations. You might be contemplating local internet breakout. No matter where you are on this roadmap, or if you just want a once-over or a third-party neutral ideology, ANM's here to help. And we're very, very looking forward to meeting up and continuing these conversations. Once again, I appreciate everybody taking the time out of their day. I know we went over a little bit, but I truly appreciate all of you coming and taking time out of your day to be here. It's an absolute pleasure. And I guess we can open up to questions if anybody has any. Amanda, did we have anybody type anything?
No questions. People are just saying thank you. I will say that I just put into the chat our next webinar, Quantum Computing with Troy Bayetto, if you guys would like to register for that. I want to thank you, Phil, for sharing some valuable insights today and giving us a bunch of great information. We'd also like your feedback. Right after this call, we'll have a short survey that will pop up at the end of the session, and your input really helps us bring relevant and impactful content to this series. So finally, just thank you everyone for joining. On behalf of the ANM team, thank you for spending the day with us, and we look forward to the next session. Thank you.
Thank you.